Modern theoretical physics is stalled by a severe structural incompatibility. On one side is general relativity. General relativity is Einstein's geometric theory of gravitation that models spacetime as a continuous, smooth manifold. On the other side, quantum field theory is a framework treating matter and forces as discrete, quantized excitations of fields. But what happens when these frameworks interact? When the smooth manifold violently collides with the quantized grid, the math breaks. Try to force these two-dimensional realities together using standard analytical solvers, and the equations completely collapse. The outputs register as computational failures, paradoxes, and sharp divergences. Traditional models interpret these mathematical breakdowns as impenetrable infinities or fatal division by zero errors, forcing a complete halt to the calculation. The theory of infinity framework operates on a strict counterpremise. Mathematical infinities are not failures. They are explicitly defined as not infinity events. A not infinity event is an explicit operational boundary signaling that an object has attempted to extend far beyond its current context. Physical constants, scaling laws, and structural realities do not sit idle in a static void. Instead, they emerge strictly from the active, continuous transport of mathematical data across these exact, highly regulated operational boundaries. To bridge this gap without resorting to unprovable, higher-dimensional string theories, fundamental mathematics requires a strictly typed compiler architecture. In the TOI canon, this is defined as the tripartite morphology. By treating infinity as a crossing boundary rather than an absolute barrier, we can construct a formal protocol to safely transport exact geometric truth from one-dimensional reality into another. We must first dismantle the standard axiomatic foundations. Frameworks like Zermelo-Fraenkel set theory commit a critical epistemological error. Zermelo-Fraenkel set theory is the standard foundational system for modern mathematics that constructs complex objects starting from an assumed empty set. Beginning with an empty set forces you to smuggle pre-existing logic and structural rules into a total void. The TOI framework applies strict operational logic, beginning with a pure pre-epistemic dichotomy, a system containing only a single unknown and a single operator of symmetry. Applying that symmetry operator recursively generates the encapsulated loop, a self-regulating cycle that generates structure while evaluating invariance. Local physical existence is defined strictly by what successfully seals inside. Watch what happens when an expression hits the perimeter, trying to escape its sealed modality. That collision at the perimeter is the precise moment a not infinity event occurs. Classical models diagnose this strike as a fatal singularity. The TOI framework correctly identifies it as a simple context switch that requires a formal knotting protocol to resolve. Reality is not a universally flat grid. It is an adjacent chain of these localized encapsulated loops. Moving information between them demands a rigorous, specific mathematical vehicle to prevent systemic collapse. This schematic shows the exact compiler architecture designed to execute that knotting protocol, the tripartite morphology. Let's examine the first component, which serves as the material cause of the system. This is the Wurm. It acts as the bounding topological manifold, the continuous universe or discrete lattice. It holds the loop together so reality doesn't fracture. Next is the active operator in the center panel, functioning as the efficient cause. This is the Wurm. It is a typed, stateful mathematical operator designed to tunnel directly through the Wurm. A stateful mathematical operator is a transport function equipped with specific extraction, carriage, and re-emission protocols to maintain an object's structural typing during transition. The Wurm follows a strict sequential anatomy. It uses a head mechanism to ingest the mathematical payload, a continuous body channel to safely transport it through the dimensional tunnel, and a tail mechanism to re-emit it into the target modality. Finally, we look at the rightmost panel. This represents the final cause, or the teleological endpoint of the entire operation. This is the Wurm. It is the absolute, immutable mathematical invariant. It is the unchangeable geometric truth sitting permanently at the bottom of the phase space. The Wurm anchors the entire system. It remains completely impervious to any scalar mutations or distortions the Wurm might experience during transit. By fracturing a mathematical event into the environment, transporter, and fundamental truth, we perfectly isolate the invariant payload from the destructive chaos of crossing infinity. We must account for the physical reality of the boundary crossing. Forcing an ordered discrete payload into a continuous manifold generates violent geometric friction. This invokes the law of conservation of modality. It dictates that apparent informational losses, or macroscopic wave dampenings, during a geometric projection are never truly discarded, but rather lifted into a latent state. The kinetic friction generated by the boundary strike is systematically siphoned off and absorbed by the Wurm's segmented body. We define this stored friction mathematically as a latent tension modality, explicitly recorded as the phi residual. The phi residual is the mathematical representation of contextual tension, denoting the exact transport cost of moving an algebraic payload across a geometric boundary. The phi residual is not an error term. It is the exact, lawful algebraic penalty incurred by moving an object across a dimensional rift. To guarantee this cost is perfectly kept, the framework applies the Tri-Modal Invariance Rule, or TMIR. TMIR is an epistemological governance protocol that demands any mathematical expression demonstrates structural coherence across geometric, algebraic, and discrete projections. If the phi residual is properly accounted for, the TMIR grants the transport canonical sealed exactness or monitored status, filtering out false numerological mirages. The phi residual provides the proof. Dimensional friction does not destroy mathematical truth. It simply requires uncompromising latent accounting to keep the underlying core geometry intact. To definitively prove the validity of this compiler architecture, the TOI analytical engine was fed a highly specific, transcendental payload. The payload was the complex double integral of an inverse complex cosine containing the golden ratio, evaluated directly across the orthogonal identity plane. This plane is a pristine continuous geometric space where the internal scalar of the golden unit completely annihilates itself, establishing a perfectly neutral vacuum. This continuous plane acts as the Wurm. It provides the vacuum necessary to execute the operation without introducing external scalar decay. Because integrals are linear operators, the active Wurm flawlessly shares the phase space into two independent dimensional channels. Let's evaluate the left channel, the real axis. The volumetric projection evaluates the first term, and the math resolves down to exactly pi over 2. The real axis mathematically collapses to strictly pi over 2. It is entirely decoupled from the golden ratio scalar. The operation successfully isolated the pure, uncorrupted Wurm. Now we evaluate the right channel, the imaginary axis. The math utilizes standard integration by parts to wholly absorb the dynamic scalar deformation of the golden ratio. The active Wurm isolates the dynamic scalar to manage the not infinity transition, taking on the mathematical weight of the crossing. This resulting logarithmic payload is the exact phi residual. It represents the isolated geometric friction of dragging a circular Euclidean payload through a hyperbolic gateway. This analytic evaluation confirms the morphology. A continuous integral physically shears a dimensional space, permanently isolating the immutable geometric truth from its dynamic transport cost. We can apply the framework's broad diagnostic power across both continuous integration planes and bounded discrete lattices. In the Euler logarithmic diagnostic, the Wurm successfully takes a chaotic, complex exponential wave, passes it through any rational plane, and emits a pure rational fraction. This exact same transport architecture also formalizes algorithmic vulnerabilities in discrete computer science phase spacers, like the 32-node matrix of a checkers board. Consider the Chinook state machine. The Chinook state machine is an algorithmic navigator that evaluates a discrete game's phase space using a linear depth search and heuristic positional weights. When restricted to a bounded depth horizon, it loses access to its flawless endgame databases and must rely entirely on heuristic algorithms. A human operator can exploit this by executing a tempo shift, shuffling a piece backward and then immediately forward. This creates a temporal vacuum in the discrete lattice. The AI is forced to increment its forward-looking search clock, while the human operator's spatial advancement remains null. The stake machine is geometrically trapped. This maneuver deploys an exploratory lattice worm that forces a state of zugzwang. Zugzwang is a positional state in discrete combinatorial games where every legally available decision branch yields a strictly negative scalar weight. The AI cannot perceive the continuous manifold, so its phase space volume mathematically collapses to zero. Whether evaluating an infinite continuous math wave or forcing an AI state machine into surrender on a discrete grid, the exact same rules of modal transport dictate what structural truth survives and what succumbs to phase trapping. The dialectic between the continuous and the discrete cannot be bridged by trying to force one reality to collapse into the other. Traditional models fail at the dimensional boundaries because they lack the exact vocabulary required to map the journey across the rift. Ratifying the mathematical Wurm as a stateful, typed transport object finally provides the master compiler architecture for the universe. By categorizing reality into the bounding Wurm, the active Wurm, and the immutable Wurm, we quarantine the friction of infinity. We establish the protocol to safely transport exact mathematical truth across reality itself.